Hello all and welcome. In this video, I'm going to show you how I created this material. So this is the reference for the material and this is the output of our COP network. Let's see how this is made. If you don't have enough time to watch the full video or if you just want to support me, you can always buy the scene file from the link in the description. Or you can just simply subscribe to keep this channel running. Yeah, let's see what I have here in the scene. So I'll turn this to Houdini VK for now. So this is the viewport. So we just have a grid and I added some dicing quality to it. And we have this texture material library lock that is introduced in Houdini 22. So if I dive inside, it's essentially the COP network. So yeah, you can build your COP network and connect your output to the UST material, which comes by default when you drop the texture material library. So if I go inside, so this is the node which is making the material. So yeah, you can connect your COP outputs into your base color, roughness, etc., and that is being rendered as a material, like that is being exported as a material in the texture material library. So this makes my workflow a little bit easier. Previously, I have to use a separate COP network and then connect our material to a quick material, or I need to create a material library and I have to make a material X builder and then connect it manually. So this is like old workflow. With Houdini 22, the workflow is really improved for developing COP materials. This is so much easier than the previous system. So I started to use this from this particular project. So yeah, so whenever you drop this, it will create this material, UST material one, and you can assign it to any geometry by using this assign geometry. So I use that to assign it to my grid here, and we just have a dome light and a camera, and then just regular render settings. So ignore this, I'll delete it. That is just for just for me to write out the thumbnail for this video. So yeah, I will dive inside the material texture library, sorry, the texture material library. I'll dive inside, and this is the entire material. Let's go back once and I'll show you some quick preview. So this material is looking slightly complex at first look, but it's very easy. If you take a look at this COP network, it's comparatively really a small set of nodes here. So if you know my workflow from previous videos, this is how I try to organize my scene. So I have this one single main stream that goes from start to end, and I work on the height maps initially. So I kind of add more and more details. So I start with bigger shapes and then like adding more and more smaller shapes on top of the existing pipe or the existing layers, and that goes into the final height map, and then I extract the base color, specular, and roughness map, anything anything that is needed for my shader to work. I'll extract everything from the height map though. So that's how I usually try to work. I follow the same method here. So what you're seeing here, the most of these, like all of these, is just height map generation, and then these are some of the other maps like base color and roughness. So yeah, that is how this scene is organized. And what you're seeing here is just a preview material. So I just grab it here. So this is how I get started. So I used a constant to initiate the material, and then here I'm adding the bigger shapes. So for this material, I want to tell where the water is stored. So wherever there is a low area, or wherever the surface is pushed down, that area needs to have the waters. So that's why I named this as water patch mask. So if I have a look at here, so you can see it is just a broader noise. So it's like a big shapes. So that's why I added it as a first thing. So if I connect this to my preview material here, so the preview material is just adjusted slightly. So we have 500 divisions, and we have the height scale set to a low value here, so that we can see how it works. So basically this is what this noise is doing, just multiplying it with our constant of 1, so that gives me some like bumpy shapes. And I'm using the blur because I just want to have a broader shape. I don't want any details from this fractal noise. You can just reduce the roughness, but I found this value a little bit clean, so I just used a blur to kind of get like a smoother bumps. So yeah, that is how it looks. And then I started adding tiles here. So if you can see this, this is just a blend node set to add mode, and I'm just adding on top of what is there already. So if I move my preview material and connect it here, you can see this is where I'm adding these tiles. So this is basically the tiles node, so the tile pattern node. So by default it creates like a even tiles. So if I go to the tile pattern, it just creates like a very mechanical tiles, but we can adjust the shapes, can adjust the parameters to get something like this. This is not much different from this, but this adds a little bit of randomness to match something like this. So I'll show you what things I have adjusted. So basically I have added, I'll like to keep them closed, and then like whenever I want to adjust something, I just open it and adjust it. So that is how I wanted to work with nodes that has a lot of parameters. So yeah, I start like this, and then like I want to randomize the scale, or like first of all I like to scale down them a little bit, so that I got some extra space around each of the tiles for the tiles to work with the tiles further on. So I'll just go to the size, and then I'll change the uniform scale to varying, and then like I'll add a little bit of variation. So you can see there are some bigger gaps and smaller gaps, and you can also reduce it overall by using this slider. So you can, yeah, just ever so slightly I wanted to keep it smaller. And now once that is done, I just added rotation using this set varying mode. So you can also like have very slight value, like 3 or 4 is more than enough. And then we have this position, which is what creating this tile offset basically. So each of the tile is not arranged in a straight line, but it has slight offset. Think of it like bricks, but in here we are not going that extreme. It's going to be like a very subtle offset, but randomly we are going to do for each of the layer. So we can just use this slider to move the slide offset, but this will create uniform offset. What we need is random offset. So again, you can just set this to set varying, and you can keep this to a minimum number, and you can adjust the variation. So I'll set this to 0.1 and then add a little bit of randomness to it. So yeah, now it is not perfectly offsetted like a brick pattern, but it is slightly offsetted, so it is not absolutely straight. So that is how I set up the position, rotation and size of the tiles. And then I have added the rounded corners. It's very simple. You can just go to the first tab, the shape tab, and you can enable the round corners to just make it rounded. So yeah, that is how I made this tile pattern to create something close to the reference. And yeah, this is the main thing that drives most of the other part in the materials. So you can see there are like 2 nulls that I used here. By default when you select this, it doesn't show anything. So I'll just quickly show something. So this null is actually used in other parts of our network using the fetch node. If you saw my last video, you may know this. So you can use a fetch node, and you can just select you can just drag. Don't select it, because if you select it, it changes the parameter. So just select the fetch node and just drag the null node into the cop path. So now what happens is this null node is being fetched over here. So you just need to press this set outputs from selected cop, so that it brings in the data from the output one. So yeah, now this node is being fetched into this node. So you can keep this node anywhere you want in the scene, but it doesn't show you the connection. This helps you to avoid crisscross lines in your network, and like visually that reduces the clutter. So I use this method a lot in my scenes, if you know my workflow here. So yeah, that's why I have these 2 nulls. I wanted to use this too in some other places of my network. I'll delete this one. and you can name it as well, but I just kept it as it is because I was just lazy. But yeah, the name doesn't matter, but visually I think you should name it so clearly, so that you know what exactly is coming from where. Before I post this, I will rename this and rename this for you so that you can understand what's happening. So yeah, these are the three outputs that I get from this tile pattern basically in here. So this is the random mono. I connected the seed to the ID of the tile pattern. So this is the ID. So for each of the tile, ID is a unique number for each of the tile. What you're seeing here is not the actual color. It's just a visualization of the pieces basically. If you go closely, yeah, I connected that random number, sorry, the ID to the seed value that creates random float values for me to work with. So you can adjust this seed to change the look of the randomness, or you can adjust the ramp to control the values of the tiles. I kind of added it on top of my existing layer, which is this one, that creates this nice looking tiles. So if I don't have this randomness, everything will look flat. So if I disable it, so actually what we can do is we can connect this to the tiles. So you can see it is just every tile is extruded in same value. We are seeing some kind of variation because the surface itself here itself is deformed, but if you don't have this deformation, you will clearly see what is happening. So yeah, you can see it is exactly on the same level. So you should not use the tiles as it is when it comes to using it as a height map for tiles. You should always try to use the random mono to create this height variation. And yeah, I'll just enable this back. So yeah, that's how I have added these tiles extrusions with random offset. And we have this is the next layer I'm going to show you, which is pretty interesting. So if I connect it here, and I will make some space for the screen. So yeah, so if you look closely, we can see these are some of the details I'm adding on top of our on top of our tiles. So this is the tiles, and this is the details that we are adding in here. So I call this chipping. This is kind of a damage on the tiles. We don't see that much on here in the reference, but while I was playing with this material, I found this. I kind of like this details that I wanted to keep it so that it is looking pretty interesting than just having a plain tile. So this is kind of damage that happens to each of the tile. So I'll show you how I set this up. So in here, if you look at the tile pattern node, it exports a UV map, basically a UV map per tile. Click here and show this. So you can see this is the UV map, and this is UV map per tile. So each of the tile has 0 to 1 value along its surface. So I'm using this to apply noise. So if I turn off this, so I connected the position to my UV map that creates noise per tile. So instead, if I don't use this position, I create a bigger noise pattern overall, but I wanted this to be on individual tiles. So I connected the position to the UV of the tile pattern. That gives me something like this. But now I wanted to randomize the UV per tile. So I want to randomize the noise per tile. So what I did is I used the UV transform here. This UV transform is randomizing the UV map, the transformation of the UV map. So basically, if I disable it, you can see this is just the same on all the tiles. Now if I enable this, so we are rotating, scaling, and moving the position of the UVs randomly per tile. So that is what this node is doing. So you can just enable uniform scaling, and then you can set uniform scale min and max. It kind of scales each of them uniquely. So yeah, this is just a regular transform, and this is where the randomization is happening. So if you increase the rotation randomness, you can see each of the tile is rotating randomly. If you set this to 0, you see no variation in here. So I just had it as 180, and I had randomized the scale as well. So that gives me something like that. And if I plug it into the fractal noise, the noise is getting applied in a random way. So if I enable and disable, you can see the difference. So that gives me something like this, and I multiply this over the actual tile map. So the tile is just so if I visualize the tiles, it is just a black and white mask. It just shows where the tiles are. So I use that to multiply the noise. So you can see wherever tile is there, the noise is getting applied only inside the tile. The outside is just black value, because this black is multiplied by this noise. So we get rid of this gap areas like that. And then on top of it, I'm adding this multiply. I'll just disable it for now. I'll just show the result of this one first. So after adding that chipping, you can see this is the result. So then what this node is doing, this is actually just controlling the randomness of the height of each of the chipping. So currently, if you see, all of the tiles is having same amount of chipping. So that is what I'm randomizing it here. So if I enable this, you can see what it is doing. So it is just reducing the chipping randomly in each of the tiles. So some of the tiles is having high amount of the chipping, and some of them is just smooth. So it is also just random mono cop. So I just connected the seed value to the seed of the ID of the tile pattern. So it generates a random value for each of the tile, and I just connected it to the multiply. Like I connected it to this chipping pattern. So that creates me something like this, and this is the reason for the chipping. That is this is the reason for the randomness of the chipping. So if I preview this, this is how it looks so far. So now let's move on to the next part, which is just soft bumps. So if I connect this to the height map, you can see this is what we are creating, which is the details that we see in here in most of the tiles. So some of them are smooth like these ones, and some of them are really rough like this one. So that is exactly what I was trying here. So you can see some of them are smooth, these are smooth, and these are really rough. So let's see how I set this up with some like really minimal nodes. So you can see it is just a fractal noise that is getting added on top of our existing material. So this just push the details outwards, and the fractal noise is having high contrast. So this is kind of creating this this bump smoothness and like creating these high frequency details. So if I take a look at just the noise, you can see there are tiles which has absolutely like a 0 value, and there are areas where it is white that pushes it outwards. So if I click here and show you, so that is the details that this node adds. And if I preview this is how it looks like. So yeah, then what are these two nodes doing here? So if I don't have these two nodes, let's disconnect this. So it is still looking like it's doing something, but what happens is the noise travels from one tile to another tile. That creates a computer generated loop. The noise is not unique per tile. So if you remember, I did some randomization in here. So I wanted something like that to be happening on this fractal noise as well. So what I did is, instead of creating another UV transform here, I just added it to my UV map. So this is just the default UV map. This is just mapping from 0 to 1 like this. So if we add this random UV on top of this, what this will do is will just create that random transform on top of this UV map. And if I connect this to the position, now if you check the fractal noise, it will rotate each tile individually. So that is a pretty cool thing to do. So now what happens is, the pattern is not continuous from tile to tile. So you can see this pattern is going like this, and then it's not continuing in here. You can see here as well. So like each of the tile is unique, like having unique noise on it. So that is my ultimate goal. That is why I use these two nodes here. And if I check here, now you can see they are all like unique, and they don't have that continuous pattern on them. That is how the height map is made so far. And then I have just added a subtle distortion to get rid of these harsh edges in here. So this basically acts like a erosion in here. So if I disable it and enable it, you can see some of the tiles are like getting eroded, and the shapes are becoming more rounded instead of like really sharp. So let's see how I did that. I just fetched that tile map here. So if you want to see where this fetch node is coming from, you can just go to the view and show for selected, like the dependency links, show for selected. This will show you the connection behind the scenes. So whenever you select a node which is connected to something else, it will show this dependency link. This is really useful. You can keep it turned on. By default, it is turned off. but you can set this to show for selected, so that whenever you select a node, it shows. There is also another option, show for all nodes. This will show connections everywhere. It can be a little messier, so I try to avoid that, and I always keep this enabled. So whenever I want to inspect something, I just select it and it shows where it is coming from. That's a really handy feature. This also works for object merges in the SOP context. We have fetched the tile map in here, and I have just blurred it and inverted it. So what is happening now is the distortion is going to apply only on the edges. It will just ignore the areas where it is black. So that is why I have created this map, and this is just a fractal noise that is set to UV mode. And yeah, that is basically it. This is connected to the direction of the distortion, so that each of the tile is like getting distorted in random direction, like pushing outwards or like pushing inwards based on the direction. So this map is kind of like applied as a mask, so the distortion happens only around the edges and not the center. That's how the distortion is applied, and that is the end of the height map. So if I look at this is the final height map I have here. But there is one more thing, that is the water. So this just ends the height map of the tiles. We are going to add the water in here. So the water is just a constant level of height, so that is why I have used a constant node here. So if I connect this, you can see what happened. So basically we are just making everything flat wherever we want the water to be. So if I increase this or decrease this, you can see the level of the water is changing. So yeah, you can see what is happening here. So this is basically a constant value, mixed it like using a blend node, using a max operation here. That gives me this flat plane water. So if I increase and decrease, yeah, you can see. So that is how I have added the water level, and I have also exported this water mask in here. So based on this water level, I have to somehow isolate until where this water is spread. So what we are doing here is just displacing the surface. So we cannot use this as a mask directly, but that is why I'm doing something here to extract exactly where the water is based on the water level. So I'll show you what I'm doing here. I'll set this back to 6. I believe this is the value I had earlier, but yeah, you can adjust it later on. So what I'm doing here is I take a difference between when there is no water and after adding water. So this is without water and this is with water. So I'm comparing this and this using a blend node set to a difference mode. That gives me wherever there is difference between this and this. So whatever changes we make here is going to be exported in here. So if I increase the water level, you can see this map is changing. If I decrease it, you can see like how it changes. So it gives me the exact area where the water is filled, and I used equalize here just to get the values between 0 to 1, and I exported it as a mask water, and this is getting used in the further development of the shader. So yeah, that is how I extracted a mask out of the height map, and yeah, this is how it looks as a height map now. So let's move on, and that is the end of the height map basically. Let's move on to the color and specular creation in here. So if I move it slightly and create some space, so this part is the color map or the base color. So if I connect it to the base color, you'll see this is the color that I'm generating from the height map, and this part is the specular map. I'll quickly show what I'm doing for the height. So basically I'm using a height to ambient occlusion. So I have connected it to the height map. So it creates this occlusion map that gives you darker values wherever there is objects that are close to each other or tiles that are close to each other. And it will also create this high frequency based on the noise and based on the settings that we do here. It will also create this details inside based on the cavities and stuff. So that is very cool. And using that ambient occlusion, I'm just converting it into a color map using mono to RGB. So it's just a lazy way to create some really random colors in here. So I use this new ramp presets. So if I enable the show all button, it shows quite a lot of ramps. I picked one of them, and you can use this button to kind of resample the number of knots in it. So if I reduce this, you can see it just creates 2 values, and if I increase this, it keeps the points as it is. So you can play around to control how much of the variations you need. So yeah, that's how I created this ramp. I haven't manually created this, and I used a color correction to darken it up, and I used a HSV node just to randomize the values on each tile. So here you can see I have used fetch to fetch the ID from here, and I'm using a random mono to just generate some random values for each tile, and then using HSV to kind of multiply the values so that it is more random per tile. So if I disable and enable, you can see you can just use a simple multiply in here, but I was just playing around with the hues, shift and stuff before before ending up with this result. So I just kept it as it is for now. And then as a next step, we are using this blend node to basically set the color of the areas wherever there is water. So this is what giving you that depth kind of effect. If I go back, you can see this is the water layer, and wherever there is water, you can see it feels like it is there is some surface under it. It's kind of deeper in those areas, but it is actually not. It is just flat. But we are using this color. I'll show closely a little bit. So yeah, if I disable it, you can see it was just gray. But if I enable this, what you are seeing here is basically darker, like it gets darker and darker as the depth is more. So that creates illusion of depth. So as there is more water, this area becomes too dark, and as the height is increased more and more, so that creates illusion of depth. So if I disable it and if I go back, it's kind of getting slower. So if I disable the cache node here, so you can see it feels milky and flat if I don't do that. And I'll also print this. I'll go inside and I'll enable this now. So you can clearly see yeah, it creates that depth, illusion of depth. So that is basically the purpose of this. So yeah, that is the final color map, and I used a cache node at the end just to make my renders a little bit faster. What this node does is just calculate everything in front of this and just bake that as a image, or it just stores the data in the RAM, so it doesn't need to calculate again and again when I re-render or something. So yeah, that is the use of this cache node. So yeah, that is how the color map is made. And then we have the specular map using the same water mask here. So I took the water mask. I'll unpin this viewport here. Yeah, so we can see this. So yeah, this is the water mask, and I'm just inverting it to get something like this here and remapping it. So basically, I want the water is extremely smooth, and the other areas are rough, relatively rough. So I just want the water areas to be completely black. So that is what I'm doing here. So just using the remap to completely eliminate any variation and just have them flat around the center and around the area where it starts to mix with the rocks. There is a slight fall off. You can get rid of it if you want. You can increase this to clamp the range, but it creates nice transition between the water areas and the rocky areas. So yeah, and even the rock is not completely rough. You can see the rock is shiny because there is the rock is still wet. So to get that wet look, I had set the output max to around 0.5, so that the water is not so the rock is not completely rough. To see that properly, you'll go back to the render view. Again, I'll pin this viewport, and yeah, so to see that properly, I will set everything to max, give it a little bit of time. Yeah, you can see it is completely rough. It doesn't have that smooth watery wet look. So yeah, this is what controlling that. So if the output min should be 0 because the water is completely smooth, and the output max, you can set this to how much wet the other tiles, the other areas, should be. So if I set this to 0.5, you can see it makes the it kind of makes the rocks look wet. So if I keep it 1, this is like completely rough, so it is like completely dry. So based on the story of your material, you can adjust this to make it look wet or like completely dry. So for me, I want to refer, like I want to match to this reference, so I set it around 0.5 so that it's not completely dried out. So yeah, that is how I created this roughness map in here, and it's basically just added another rough remap here. Actually, I'm controlling the final roughness in here, but I have showed you with this one. But yeah, the concept is just mapping the roughness as how you want. So yeah, I hope that helps. That is how the entire network is made of. I took a lot of time to explain this, so kindly support me by just buying this scene file. The link will be in the description. Yeah, you can recreate it on your own, but if you don't have time or if you want to play around with my file, you can directly download it using the link below. So yeah, thanks a lot for watching. See you in the next one.